Okay, we are group number 28, and the problem we are doing is 1.71 from the first homework. This problem is basically finding out the torque required to spin the circular plate, and this is kind of tricky because you have to differentiate and integrate like multiple times, and here are some steps to solve this problem. Okay, first we are given the diameter of the circular plate, which is 12 inches. So the radius, big R, would be 6 inches or 0.5 feet. And the H, which is gap between two plates, and it is 0.1 inches. And we have omega, which is angular velocity, is 2 revolution per minute, and we need to convert this to radian per second, so it's basically 2 revolution per minute times minute over 60 seconds times 2 pi radian, which is 1 revolution, and we have 0.209 radian per second. Okay, and let's do the diagram. So here's the circular plate, and we have big R, which is radius, and here's a small r. This one is the distance between the center to the point of boundary caused by shear stress, which is tau. And shear stress is acting on the bottom of the plate, and the direction is counterclockwise. Okay, next we're going to do some calculations. So we don't know F force is equal to tau times area, and torque T is equal to force times radius. So if you plug this force to this equation, you're gonna get the torque is tau times area times radius. Now we differentiate torque with respect to the area, then we have dt is equal to tau r dA, and the area A is simply pi r square, and we differentiate the area with respect to r this time, then we have dA is equal to 2 pi r dr. So we plug this dA to the torque equation, then we're going to get dt is equal to tau r 2 pi r dr. Now to find out the torque, we have to this time integrate. So we're gonna get torque is equal to 2 pi integral from 0 to big R square tau dr. Next, we know tau is equal to mu times du dy, and mu is viscosity of glycerin, and du dy is v over h, and this v is radius times omega. And here's a fluid velocity profile, and you guys are all familiar with this. So two plate, and here's h, so u, y, and this is v of this plate. The velocity of this plate is equal to radius times omega. So eventually we're gonna get tau is equal to mu r omega over h, and we plug this tau to the original torque equation, then we are gonna get torque is equal to 2 pi mu omega over h, integral from 0 to big R, R cube dr. And if you do the calculation, we're gonna get 2 pi mu omega over h times quantity r to the fourth power over 4. The last part is just plugging in numbers. So we have torque is equal to 2 pi times 0.4313 second over square feet times 0.209 radian per sec times 6 over 12 to the fourth power all over 0.1 over 12 times 4, and you're gonna get 0.0772 feet pound for the final answer. And this number is viscosity of glycerin. You can find this number on table 1.5, the front of the textbook.